In this video, we're going to see what to do if you have a translation in the horizontal direction or the vertical direction, and a reflection, meaning that it's flipped upside down. So this is an example where that happens. We have a -2 in front. With the negative sign, it's telling you that there's a reflection, that it's flipped. And we can see already that there's this -h here in the middle that's going to shift the graph to the right pi over 2, or it's going to shift the graph over 90 degrees. However, the steps for solving these is exactly the same as 14.2a. The first step is going to be to identify the amplitude, period, horizontal shift, and vertical shift. The amplitude, in this case, is the absolute value of a, which is -2 is a. So the amplitude is a +2. We're going to identify the period, which is 2 pi over b. In this case, it's 2 pi over b, which is 2/3. And when you have 2 pi over a fraction like that, this is something that we still need help with. It's 2 pi times the reciprocal of the fraction. That's how we divide 2 pi by a fraction. The 2's cancel out, and the period is going to be equal to 3 pi. To find the horizontal shift, in this case we know there will be one. We just identify it very simply as the horizontal shift is h equals pi over 2. Remember, if its horizontal shift is opposite, so even though it says -pi over 2, it's opposite, so the horizontal shift is shifting everything to the right, pi over 2. And the vertical shift is the plus k bit. Of course, there's nothing over here, so the vertical shift is just none. So for this graph, it's going to be a sine graph with a period of 3 pi, amplitude of 2, horizontal shift of pi over 2, and no vertical shift. Okay, I went ahead and cleaned up what we already found out, just summarized it up here. Now on to step 2. Step 2 is to draw the midline of the graph. And the midline is equal to the vertical shift. So in this case, the midline is just y equals 0. Or that's the same as the x-axis. Let's go ahead and draw that in. Might have to move this as well later. Okay. Step 3 is going to be to find the 5 key points. And this is a sine curve, so we know there are going to be 3 x-intercepts, or 3 zeros, 1 maximum, and 1 minimum. So let's go ahead and find those. Okay, I don't think I'll ever be able to reference this picture enough. This is the one that is going to help you with this entire section. You should be very comfortable with this by now. So this is a normal sine curve if everything was normal. However, in this one, we have a reflection and a horizontal shift. And we've already solved for the 4 things that we need to solve. So what you need to realize is a horizontal shift is going to change every x value. So this is normally what the x values are. That's normally what they are. However, if there's a horizontal shift, all of those x values are going to be shifted the amount of the horizontal shift. So here it's pi over 2. So when you find your x values, you're going to take that and then add pi over 2 to it, because everything is moved to the right. This does not affect the y values. Y values would be affected by this, the vertical shift. However, there's no vertical shift. So all those x values need to be, when you find them, you need to add pi over 2. And I'm just going to go ahead and do that. So the first point would be 0, 0, but it's really 0 plus pi over 2, 0. So it's just 0 plus pi over 2, 0, which is equal to pi over 2, 0. That's our first point. Let's find this one in the middle. It's 1/2 times the period. The period is 3 pi plus pi over 2, 0. So we have 3 pi over 2 plus pi over 2, 0, which will give us 2 pi, or 4 pi over 2, 0. So that's our second point. First point, second x-intercept. Let's go ahead and find the third one. So the third one would be the period, 2 pi over b, that's the period, 0, but it's the period 3 pi plus pi over 2, comma 0. And the way to think of it is this is 3 pi is really the same as 6 pi over 2. So we have 7 pi over 2, comma 0 for our last intercept. Now we need to find our maximum and minimum. So the max is 1/4 times the period, 3 pi, plus pi over 2, comma a, which is the amplitude, which is 2. So that's 3/4 pi plus pi over 2, comma 2. In order to add those together, they need like denominators. Pi over 2 is the same as 2 pi over 4. So we can add those together as 5 pi over 4, comma 2. That's going to be our maximum. Now we just got to find the minimum. It's 3/4 times the period, pi over 2 pi over b, plus pi over 2 for the h, comma negative amplitude, which is negative 2. So the first one, we get 9 pi over 4 plus 2 pi over 4, that's 11 pi over 4, comma negative 2. So those are our last 2 points, 11 pi over 4, comma negative 2. Now, when there's a negative number in front, that means we need to reflect it. And in order to do that, we're just going to change these two values right here. So instead of 5 pi over 4 and 2, which is the maximum that we found, we're going to reflect it, so that's actually going to become the minimum. So the new point is actually 5 pi over 4, negative 2, and then this minimum is going to become the maximum. We have 11 pi over 4, comma, positive 2. Now the last step is just going to draw the graph. And one of the hardest things, I think, at first is setting up the graph correctly. Because how are you supposed to do it? You know, you have all these points, pi over 2, 2 pi, 11 pi over 4. What are you supposed to do? Well, my suggestion is really just draw a tick mark for every part of the denominator. If the denominator is broken up into fourths, we need at least a mark for every 1/4 pi. We need pi over 4 and 2 pi over 4 or pi over 2. 3 pi over 4, and pi. So we need marks like that. I might need to put these a little bit closer together. But that's how we're going to decide where to draw our marks. It's just every time the denominator splits up. So we need pi over 4, 2 pi over 4, 3 pi over 4, pi. So now we can draw our points. So we have pi over 2, 0. Let's go ahead and put the first one in. So pi over 2 is going to be here. Because it's halfway between 0 and pi is pi over 2, or 90 degrees. The second one is 2 pi, comma 0. And the third one is 7 pi over 2, 0. So this is 6 pi over 2. And we need 7 pi over 2, which is halfway between 3 pi and 4 pi. Okay, now we need our minimum and our maximum. So it says 5 pi over 4, which is going to be here, which makes sense because it's halfway between the intercepts. And if this is pi or 4 pi over 4, this is 5 pi over 4. It's 1/4 more than this dash. So 5 pi over 4 and go down to negative 2. We just get to make that up. We'll just put it there. Then we need 11 pi over 4, comma 2. So 11 pi over 4, I guess that's 12 pi over 4 would be 3 pi. So 11 pi over 4 should be 1 behind it. We'll go up to 2, put a dot. So this is what our graph is going to look like. And then of course it keeps going in both directions. Okay, so I wanted to include a little bonus at the end of this video to show you how you can graph this using a calculator. Um, of course, using the calculator really doesn't work because you need to know the parameters already, but I wanted to show you how you can model what you put on paper to look perfectly in a calculator. So because I already know where these points are, I can adjust the window to perfectly fit it so we can see the same thing. So I typed in the equation just like I needed to, being very careful to put in the parentheses where they go, and you can see that as well. I approximated 2/3 as 0.6666 repeating, and I hit graph. And of course what it looks like is this. That's what the sine curve looks like. But we only care about this section because that's the part that we graphed, so we need to change the window a little bit. So let's think about this critically. What do we want the window to be, the x-min and x-max, and the scale itself? So the most interesting thing about is probably the scale. So in our scale, we said pi over 4 was each line, so that's what we want here as well, pi over 4. And it'll calculate that for you. So that means each line on this graph in the calculator will represent pi over 4. For x min, well, we started at 0. We can put that here as well. For x max, we only care that it goes over here to about 4 pi. So let's just put 4 pi. For y minimum, we know that this graph goes down to 2 and up to 2. So let's just go one more than that. Let's just say put the minimum at -3 and the maximum at 3. For the y scale, we also don't really care about that. On my graph, I just went by 1, +1, +2, -1, -2. So I'm just going to leave that. And I'll hit graph. And now we have the same thing we have over here. If we check it out, it goes through perfectly at the points we thought it would. It goes through perfectly right here at pi over 2, 0. Goes through at 2 pi. And at this last point over here, 7 pi over 2. And it goes through at the maximum and minimums we thought as well. So this is a good way to check your work. After you've graphed it, this is a good way to verify that you got the right answer.